Hi, my name is Tommy Hendricks. I'm with San Jacinto College Central. We are located here in Pasadena, Texas, and I'm actually the program coordinator here for what's known as the FAST Automotive program, and that's just an acronym that stands for Future Automotive Service Technicians. Um, the reason why I'm making this video is I really feel our program could benefit from ConsuLab, or really, especially some of your training modules I've seen. They're pretty impressive, and I feel that could take what I teach in the classroom and take it to the next level. And I'm actually working on a couple innovations of my own that I can feel will really help our students understand some of the more complex systems. Like I have some electrical demonstrations to really illustrate that concept that's very, very hard to visualize and see what's actually happening with anything electronics, or even for something like transmissions or final drives. I've got something in the works as well, and I'd like to show that to you. So I kind of wanted to show you some of the innovations that I've been doing, some of these personal items I've made to help bring my teaching to the next level, to really help the students understand what exactly is going on. So right here we have the basic concept behind how a motor operates. Right here we just have this whole armature assembly and copper pipe made into a little commutator assembly. I took some solid wire, the specific wraps. We have a coil right here, coil right here. Whenever you send current through the commutator bars on opposing ends, of course, once it flows, generates a magnetic field. Then we have two opposing magnets, and of course, the interaction between them is what causes that to rotate. And that's exactly the principle behind how a lot of these DC motors work. So once they see that, everything sort of makes a lot more sense. So right here we have another display piece that I made, and this is to help illustrate to the students the differences between a series and a parallel circuit. So right now we have a printed circuit board with 4 relays, and they're wired in such a way that whenever we flip the switch, it'll actually switch automatically between a series and a parallel circuit. So when we turn this on, right now this is wired in series, and that is reflected in the overall current is 2 amps. These are fairly dimly lit until we switch over to a parallel. And I don't think you can see in the camera, but this needle from the A meter actually spiked up to 9 amps, and the overall brightness of this, as you can see, has increased. Another cool thing is whenever you pull the bulb out, parallel circuit, it won't affect this until you switch it over to series, because now you've essentially created an open circuit whenever you've taken this bulb out until the connection is restored. You replace the faulty bulb. We attempt to plug this back in, and connection is restored. So here's another cool display board that I made fairly recently. It's going to take an input of 12 volts, step that up to 20 or 30,000 volts, and really that's the basis behind how a lot of modern ignition systems work now for gasoline engines for the final combustion process via these ignition coils right here. That's why I also did a little cutaway model of that ignition coil, so the students can see the difference between the primary and the secondary coil on the number of turns of the secondary versus the primary, and how the interaction of the magnetic field collapsing or changing will actually induce a very, very high voltage in the secondary. So here, another custom printed circuit board with a 555 timer, and we have a little potentiometer input that's going to directly correlate to how quickly the gate of the transistor switches the primary circuit on and off of these ignition coils, which will directly affect the output right here. So what I'm going to do is press the switch, start changing that input to the timer, and that's going to directly control the output going to these spark plugs, which is reflected in the overall strength as I dial it up, and you can hear it as well. So another cool innovation I can bring to the classroom is that I actually have access to the CAD software at my home, and I'm able to draw up and design some stuff. Granted, my knowledge on CAD is fairly limited, but I'm still learning. It's a day-by-day process. But to give you an idea, it's a little HID bulb holder I designed and made so that I'm able to take this, convert it to an STL file, convert it to a G code to where I can actually 3D print out the final product. So the bulb would actually go into here. It's a twist, lock in place, and be good to go. So it'd be a little display board that this lower portion would actually bolt or screw in place. And this will eventually be a display board for the ballast and igniter unit for the HID xenon bulb assembly. So the really cool thing about 3D printing is that you're able to bring a lot of innovation into the classroom. And there's just so much potential with 3D printing out there that, I couldn't resist getting one. This is printed off my own 3D printing device at home, and this is a working torsion differential model. This model I didn't design. All of this is available online for anybody to download if they have a 3D printer and print it out, so they can really see how things work. But this is, you can see why this is a very effective teaching tool. So this will represent your drive shaft attached to the pinion gear. When you rotate this, it rotates the ring gear, which in turn rotates the whole carrier assembly. And when you rotate this, you can see both drive wheels spin at equal speeds. Until this represents, if I hold one drive wheel where you're cornering, you can see what happens with the worm wheels and worm gears within the carrier assembly. See how they rotate around? So again, very, very cool teaching tool, and that's sort of the aha moment that students see when they start realizing how this works. So very, very cool. So this is the 3D printer I use. This is a Prusa i3 MK2. And this is what I used to print a lot of the components I actually showed you. And what we have in here, I actually just got back home from work. This is going to be an intake manifold for a Subaru WRX EJ20 engine, and I can actually show you real quick. And this enclosure I actually built as well, and that's going to help print some of the more trickier filaments. But if you look back here, this is going to be a working model engine, Cutaway model, and again, there's no way I had this much talent to design this. This is actually designed by Eric the Pool Boy, someone on Thingiverse, and complete working model, accurate model of an EJ20 engine, and again, very, very helpful tool for sort of understanding the different engine cycles, and this is a different type of engine, and it would be very, very helpful to show the students this in the classroom. Okay, so this is one of the last things I wanted to show you guys. I've been working on this for a little while. This is one half of a high voltage transaxle unit, and on the back side I've actually done a cutaway so the students are able to see MG2 and how it interacts with the large stator windings. And really the ultimate goal is to use some sort of variable frequency drive to drive the rotor MG2 via pulse width modulation. So that'd be a really cool display piece. But in the meantime, I've actually constructed this unit, and I'm actually going to put this on and explain what my reasoning is behind this. So I'm going to put this on real quick. And what this does is this will bolt down to the case and retain everything in place, so the students are able to actually see the workings of the final drive assembly whenever the motor generator is actually running. But another thing you can do is what I'm planning on doing as well, if you look down here, I'm going to draw up and design a shaft to interact with the side gears and that pinion shaft down there to where the students are able to take and rotate this, which in turn will rotate the large rotor, the motor generator too. And what you can do is hook up a load to it like a light bulb, and they can feel for themselves just how much effort it actually takes to generate the electricity to light the bulb. And you can also short the windings out, and it will effectively lock up the entire unit. It was very, very common to, if a stator windings were shorted out, the vehicle would be towed in and the wheels were locked up. So just another couple ideas that I've been working with. Hopefully this will show you some of the innovations that I am attempting to help bring into the classroom to help students sort of understand some of the more complex systems. And really and truly, this is something I'm really passionate about, and I hope that shows in some of the projects I'm sort of undertaking on my own. So I want to thank my good friend Roy for helping me out with some of the electrical designs for the printed circuit boards you saw. And I also want to thank you guys at ConsuLab for giving me this opportunity to sort of help represent my college. So thanks again, and my name is Tommy Hendricks. Take care.